Hey everyone, welcome to Ambition. In this video, I am going to discuss about solid state relays, how to build a driver circuit. Now, there are many companies that manufacture SSRs, but I'm going to discuss the one available in the market, that is Unison. Now, the one the circuit that we are going to design has for this SSR has an input voltage of 3 to 32 volt DC, 4 to 16 milliampere current, and you can control your AC circuits with this. No, first of all, there are four types of SSR available in the market. There's an instant on solid state relay, zero switching solid state relay, peak switching solid state relay, and analog switching solid state relay. Here are the advantages of SSR. I'm not going to discuss all the advantages, but you can just pause the video and go through it. Or you can find it on any web page if you just find the advantages of SSR. Also, there are some disadvantages, but advantages outweighs the disadvantage very much. Now, if you want to build a robust and a long life product, and you are going to use relays, then it is better to choose SSR. Though it is costly, but your product life expectancy will highly increase. Now, this is the circuit diagram for solid state relay. This is the Unison SSR. This is the current limiting resistor. I have a 12 volt. Let's say 12 volt is applied to the SSR, as we can give any voltage between 3 to 32 volt DC. But make sure that the current specification remains between the 4 to 16 milliampere. You can connect your output AC load here. Using this SSR, we do not get normally open or normally closed type of contacts. This is simply a switch that if you go over voltage, it will switch and there will be only one output, that is single contact. Now, these are our input specifications, that is 4 to 16 milliampere current and 3 to 32 volt DC voltage should be applied to our input. And now you can give directly DC voltage between 3 to 32 volt DC. I have talked to the Unison person and he told me that you can connect. But to make sure that the current limit that does not go beyond, I have added a resistor that limits the current even further. Also note that the current should not go below the rated, because if the current goes below the rated specs, then our SSR will not switch. So we have to select our resistor wisely. Let's say I have chosen a current to be flowing in the input circuit to be 10 milliampere. Then the resistor should be 1.2 kilo ohm, because input voltage is 12 volt that we I am supplying. Now, for a production basis, 1.2 kilo ohm is a rare resistor. Instead of that, you can choose 1.5 kilo ohm or 1 kilo ohm resistor. But or you can make a series of 1 kilo ohm and 200 ohm resistor. But to use this type of series, it is not advisable, as it also increase our cost of the product. Let's calculate the current for both the resistor that we are choosing, 1.5 kilo ohm or 1 kilo ohm. Let's For 1 kilo ohm the current will be 12 milliampere that will be flowing in the circuit, and for 1.5 kilo ohm it will be 8 milliampere. So both these resistors are equally selectable, as the rated specs for the current are in means the current is rated between the rated specs. But as soon as we buy SSR from the market, we don't know that there is an internal resistor added or not. Usually there are internal resistor added, so you can give 3 to 32 volt DC directly. But uh, if to limit our current, that to make sure that our relay does not get damaged, we are going to add a current limiting resistor in series. As you all know that if two resistors are in series, then the sum of the total resistance, that is effective resistance in the circuit, will be R1 plus R2. So let's say if internal resistance is 1 kilo, then if R2 is 1.5 kilo ohm, then our resistance, total effective resistance would be 2.5 kilo, and the current flowing in the input circuit would be 4.8 milliampere. Also, if resistor is 1 kilo ohm, internal resistor, then not internal resistor, our current limiting resistor, then the current will be flowing in the input circuit will be 6 milliampere. So you can see that if we choose 1.45 kiloampere, then the current flowing in the circuit will be much nearer to the rated specs, that is 4 to 16 milliampere current. Rather to choose 1.5 kilo, it is better to choose 1 kilo. Do like, share, and subscribe.